Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in the last lecture we have did a numerical which was based on percentage composition, and now we are going to do a numerical which is based on percentage composition as well as the molecular formula of a particular compound. So let us do it. So friends, this is a numerical which is based on percentage composition, and we have to determine the molecular formula of that a particular compound. So the first thing that we should do is we should analyze what is the given data that is being present in the question. So let us understand the question itself. So it says that a compound known to be composed of only carbon, hydrogen, nitrogen and oxygen, which contains carbon as 49.3%, by that of hydrogen as 9.59%, and the nitrogen as 19.18%. So we have to find its empirical formula. Its molecular weight was found to be 146, that it has been already given, and the next thing is we have to calculate the molecular formula of that particular compound. So the first thing that we have got the data as, we have got percentage of carbon, percentage of hydrogen and percentage of nitrogen. But the important thing is they have also given that the compound contains oxygen. So in this case they have not mentioned the percentage of oxygen, so we have to calculate the percentage of oxygen. It is very much simple, as we have did a lecture that was based on the relationship between empirical formula and molecular formula, in which we have studied in point number 1. So now we are going to do is we are going to follow that relationship, and now we are going to solve this numerical. So the first thing is, in the given data, the percentage of mass, the percentage mass of the carbon, which is given as, which I'll write it as 49.3, while that of the percentage of hydrogen is given as 9.59, while that of percentage of nitrogen is been given as 19.18. So what would be the percentage of oxygen, because they have also mentioned that there is a presence of oxygen in the compound. So what we are going to do is, it is very much easy to analyze, that is we will sum up all the elements that the percentage that they have given, and we will subtract it by 100. So what we are going to do is 100 minus 49.3 plus 9.59 plus 19.18, and let us see what is the answer that we could get. So we have got the percentage of oxygen as 21.93. so this is how we have calculated the percentage of oxygen. We have already given carbon, hydrogen and nitrogen's percentage, and now we have calculated the percentage of oxygen, that is 21.93. So to determine what will be the empirical formula, I have drawn a particular table, so that it would be very much easy so as to calculate all the number of moles of the particular atom that are being present in the compound. So this is a table that we have to draw, and we have to make sure that we are going to draw this kind of table itself, so as to make it very easy to calculate the empirical formula. So the first is for element, the next is for the percentage by mass of that element, then the number of moles of that element, then the atomic ratio, and then the simplest ratio that we have written here. So now the first element that they have provided to us is for carbon, and as we know, the percentage is given as 49.3, so I'll write it here, while that of the other element that is being present, that is of hydrogen, which has a percentage of 9.59, while that of the nitrogen is given as 19.18, and while that of the oxygen that we have calculated, it was found to be 21.93. So this is how we have make a tabular form of the percentage by mass of the elements that are being present in the particular compound. So this is how we have calculated percentage by mass. But the next thing that we have to do is we have to find out what would be the number of moles of each element that is being present in the compound. So the first thing that is, we know that how to calculate the number of moles. It is nothing but the weight divided by the atomic weight of the particular element. So in this case the weight is been already given, that is 49.3, but when I calculate the number of moles for carbon, and as I know that the molecular weight of or the atomic weight of the carbon is nothing but 12, so what I am going to do is I'll divide 49.3 with 12. So let us see what is the answer. So we have got it as 4.10. So this is the number of moles of carbon that is been present in that compound. Now moving towards the next one, that is we can calculate the number of moles for hydrogen also. This is the number of moles of this is the percentage of mass of the hydrogen, and we can determine the number of moles because weight divided by atomic weight of the hydrogen is nothing but 1. So therefore 9.59 divided by the atomic mass of hydrogen, which is 1, it will lead us to give 9.59 itself. And now moving towards the next one, that is for nitrogen. So again we know that the atomic weight of the nitrogen is nothing but 14. So I'll divide 19.18 divided by 14. So we have got the answer as 1.37. While that of the oxygen, we have the atomic weight of oxygen is nothing but 16. So therefore we will divide 21.93 with 16. So let us see what is the answer. We have again got 1.37. So this is the number of moles that we have got while solving this kind of numerical. So the first thing that is we have already calculated the number of moles, and the next thing that we have to do is we have to determine the atomic ratio of each and every element. So in this case, if I would see that the 4.10 which is a higher number compared to 1.37, and the highest number is 9.59, and again this number of moles are not being present in a whole number ratio. So what we are going to do is we are going to divide this each number of moles with the smallest number of moles that we have obtained in this process. So the smallest number is nothing but 1.37. So we are going to divide 1.37 with each number that we have got. So suppose if I divide 4.10 with 1.37, then let us see what is the answer. We have got it as 2.9. Basically I could write it as 3. 2.99, basically I could write it as 3. And now I will divide 9.59 with the smallest number of moles. In this case is again, that is 1.37. So I'll divide it. So if I divide 9.59 divided by 1.37, then the answer that I could get is 7. And now the next one, suppose if I divide this 1.37 with the lowest number, in this case is nothing but 1.37 itself. So 1.37 divided by 1.37 is 1, while in this case also 1.37 divided by 1.37 it will be 1. So basically by following the steps of the empirical formula, how to determine the empirical formula, in which one step had included that if we divide the number of moles with the smallest number of moles, then we'll get at least one value as a unity. So in this case we have got the unity values. So this is how we have understood that determination of empirical formula also, and in this case also we have determined numerically. So let us see that what would be the simplest ratio of this 3, 7, 1 and 1. So we can't multiply with any number. Suppose if 1 is already been present, so if I want to make it a simple ratio, I can't multiply it by 2. Suppose if I multiply this by 2, then the number will be 2 itself, and that won't be a simplest ratio. As well as this atomic ratios are been already present in a whole number, so we don't have to multiply it with any integer. So therefore the simplest ratio is nothing but 3, 7, 1, 1 itself. So this is how we have determined the empirical formula, and now we could write the empirical formula very much easily because we have got a simplest ratio of each and every element that is being present in the compound. So the empirical formula will be the empirical formula for the compound will be, because it contains carbon and carbon has got a simple ratio as 3, so therefore C3. Hydrogen, which has got the simple ratio as 7, while that of nitrogen has got the simple ratio as N, which is 1, while that of again oxygen, which has got the simple ratio as 1. So this is the empirical formula of that particular compound. So once we have got the empirical formula of that particular compound, it will be very much easy to calculate what would be the empirical formula mass of this particular compound. And how can we calculate it? It is very much easy. So the next thing is the empirical formula mass will be, it is very easy to calculate because carbon is 3 times which is present, while that of hydrogen, which is present 7 times, while that of nitrogen, which is present 1 time, and that of the oxygen, which is also present 1 times. So what I'm going to do is I'm going to multiply by the atomic mass of each and every element. So in this case, for atomic number of carbon, we know it is 12. So 12 multiplied by 3 plus hydrogen, the atomic mass is nothing but 1, multiplied by 7, while that of the nitrogen it is 14, while that of the oxygen it is basically 16. So if I calculate this thing, so let us see what is the answer that we get. So we have got the answer as 73. So this is the empirical formula mass that we have got as 73. But the next thing that we have already got a value of molecular mass. So let us see. The molecular mass of compound which is given to be 146, and now we have calculated the empirical formula mass also, that is 73. So now the factor N has the formula as continuation of the numerical. So this is the N factor, which has a formula like molecular formula divided by the empirical formula mass. So we could calculate it very easily because the molecular formula that is being given as 146, while that of the empirical formula mass that we have calculated was found to be 73. So if we calculate, or if we divide this thing, so let us see what is the answer. It is nothing but 2. So the value of the factor, that is N, is found to be 2. But this is not the final answer because we have to calculate the molecular formula. So now what we have a relationship between the molecular formula and the empirical formula is the molecular formula is equal to N, that is the factor that we have got, N into empirical formula. So the value of N that we have recently calculated is found to be 2, while that of the empirical formula that we have calculated is found to be, that is C3, H7, N and O. So in this case, what I am going to do is I will multiply the number with 2. So the elements, which is for carbon element, suppose if carbon is present 3 times, then what I am going to do is I will multiply it by 2. So now therefore the carbon will be now 3 into 2 is 6, while that of hydrogen, which is now 7, when I multiply it by 2, it will be 14. So therefore H is equals to 14, and while that of N, that is nitrogen, it also be multiplied by 2. So therefore N is 2, and while that of the oxygen, which is present here 1 times, if I multiply it by 2, it will be 2. So this is the molecular formula of that particular compound. So in this case, what we have got to know is that the empirical formula and molecular formula, they both differ. They both differ by an integral multiple of 2. So therefore, this is how we have calculated the molecular formula by using the percentage composition, by the help of percentage composition, as well as the determination of empirical formula. So this is the numerical that we have did. So I hope you are going to do this kind of numerical in your future also, and try to do this kind of numerical more and more, so as to get more confident in this kind of numerical if it comes in your exam point of view. So thank you friends for watching this video. I hope you have understood this video, and share this video with your friends, and yes, don't forget to subscribe Ekeeda channel. Thank you so much.